Hi everyone, I hope all of you are doing great. So in today's lecture, we're going to see another very classical problem of dynamic programming, which is called count subsequences of type a raised to the power I, b raised to the power j, and c raised to the power k. So this is one of those problems which is very frequently asked in interviews, and it's one of the very it comes in a very famous category of dynamic programming question. So, the good thing about this problem is that in interviews, this problem is asked directly. So, I've read multiple articles on Geeks for Geeks and Lead Code where I've seen, people mentioning this question that, this question got directly asked, right? You've seen a lot of problems, right? 0-1 apps, right? And some other problems as well, right? There is possibility that those problems can be, altered, right? And, to form a different problem. But this problem is generally directly asked, right? So let's see what the question is saying. So you are given a string S, right? The task is to count the number of subsequences of the form AI, BJ, CK, right? Where I is greater than equal to 1, J is greater than equal to 1, K is greater than 1. So they cannot be 0, right? This is the question, like single liner question. If this comes in an interview, it's very hard to understand what the question is saying, right? If this explanation is not given, right? If this explanation is not given, right? Which is generally not given in, online interviews itself, right? But let's look at the board. Let's go to the board and try to understand what this question is trying to say. Let's try to understand what the question is saying. You want to count the number of subsequences which are of the form a raised to power I, right? B raised to power j and c raised to power k. Now, these are all powers and they kind of represent repetitions, right? So, for example, let me write a subsequence which is, taking this form. So, if I say, let's say there is a subsequence called A2, B1, C3, right? So, this subsequence would look like this. So, A is 2 times, B is 1 time, and C is 3 times, right? So, this is kind of repetition, right? By power, we mean they are repeating, right? And you need to find the subsequence like this only. What I'm trying to say is that in that particular subsequence, whatever you have to count all the possible subsequences of a string. And what does that subsequence have? That subsequence should have a multiple a's. After multiple a's, there should be multiple b's. Single can also be there, right? And then multiple c's. So you cannot say a c b is is taking this form. No, not at all. Right? You cannot say b a c, or let's say c b a is taking this form. No, only you have to count the subsequences which are of the form first a should come, then b should come, then c should come. I hope the question is clear to all of you. Let's take some examples, right? When the question is trying to, when a question is kind of difficult to understand now, what we always do is we take some examples, right? We iterate over example test cases and try to find the correct answer. So I've written some three test cases here which are very good test cases, right? The first test case is that count how many number of subsequences you can form of type AI, BJ, CK out of this ABC. Yet only one subsequence can be formed, that is ABC. So count for this will be 1. I think it's not clear, but let's move to the second, these two things where, B, C and these things are getting repeated, right? So what I'm going to do is let's consider this particular test case. So A, B, B, C, right? Just for the sake of understanding, I'm going to mark this second B as B dash, right? To, mark that this is the second B I'm talking, correct? So let's write all the possible subsequences. So first subsequence would be A, B, C. Let's consider this A, B, C. Second subsequence would be A, B dash C. A, B dash C. I hope the difference between subsequence, subarray and subset are clear. These are very three different, you can say completely three different entities, right? Subsequence, subarray and subset. Here we are talking about subsequences. So ABC is one of the subsequence, A, B dash C is one of the subsequence, and another subsequence can be like this, A, B, B dash C. And since there are no A's repeating, no C's repeating, only B's are repeating, and we have tried all the permutations of, all the different combinations of B, we can simply say that yes, we have found the answer. And, there are total three different subsequences we can count out of the string, which are of the form AI, BJ, and CK. I think that it's still not clear. Let's take this example. This is a very good example. Let's see what we can choose, right? So let's consider all the subsequences. I'm going to one by one write down all the subsequences, right? So A, B, C. One of the subsequences, for the sake of understanding, the second A, B, C, I'm going to mark with dashes, right? So the first subsequence would be ABC normal, general ABC, simple. Second subsequence will be this A dash, B dash, C dash. A dash, B dash, C dash, correct? Third subsequence we can consider, right? So A, B dash, C, right? A, B dash, C, correct? This is also one of the correct answer, right? Another subsequence we can, target is A, B, B dash, C, C dash. So here should be C dash, right? So A, B dash, C dash, and A, B, C dash. This is also one of the possible subsequences. A, B, C dash. Correct. Another one is A, B, B dash, C dash. A, B, B dash, C dash. Of course, it is of the form A, B, C, right? First A's are coming, then B's are coming, then C's are coming. Similarly, here as well, first A, then B, then C. Let's find out some more. Let's try to find out some more. So let's say A dash, B dash, C. This is also one of the thing. So A dash, B dash, C dash. Of course, C dash is there. This is also one of the thing. What else can we find out of this? Let's try to find out. So 1, 2, 3, 4, 5, 6. One more is there in this particular array, which is hiding in plain sight. Of course. So the last one is, this A, B, C, C dash, right? This was not being covered, right? So these are all the 7 possible, A, I, B, J, C, K subsequence we can form out of this particular string. So answer for this particular thing would be 7. Answer for this test case would be 3, right? Again, I'll draw. So A, B, C, A, B dash, C, A, B, B dash, C. Like these are all the 3 possible subsequence we can form out of this particular thing, and from this particular string we can only form 1, right? So I hope the question is kind of clear to all of you, right? What we are going to do in this problem now, we can definitely go and understand the recursive way to solve this problem, but trust me, the recursion way of solving this problem is kind of trickier than the tabulation way. It is much more easier and easier to solve and easier to remember the tabulation for this problem. So what we are going to do in this video, we are going to discuss the tabulation approach for this problem. But down in the description, you are going to find the link to the repo of this particular playlist, and in that repo you are going to find the code for this video, and there will be recursive code as well for your reference, right? So let's quickly see how we solve this problem. And trust me, if you study this problem through tabulation way, this problem actually sticks to the mind for some reason, right? All the students as well, like for all my students as well, say this, that this particular problem actually stays in the mind, the tabulation way itself. Otherwise, for other problems, I always say that you should always first try to find out the recursive way, first try to find, because that is easier way to do, right? But for this problem, for some reason, it sticks in the mind, right? So let's quickly see how we solve this problem through tabulation and then move forward. So this is the kind of tabulation we are going to make. Basically, what we want to say is that these are all the indexes of that particular string. So let's say this is the string given to us, ABC, ABC, right? For the sake of understanding, I have marked this second pair of ABC as A dash, B dash, and C dash. Now, we are having 3 rows here, and every row represents certain, let's say property. This row, in this particular row, I'm going to write all the subsequences which are ending with A. In this particular row, I'm going to write all the subsequences which are ending with a B. And similarly, for this row, I'm going to write all the subsequences which are ending with a C. Correct? Let's start it, right? So let's consider the string till here only. You just have to consider the string till here only. First, you're going to fill this whole, tabulation form through logic. I'm not going to, share any formula or something like that. Let's try to fill through logic only, right? So just look at the string till here. How many subsequences you are able to find with which are ending with only A? Single A. This only. How many subsequences you are able to find which are ending with B? None. I am going to keep it empty. How many of the subsequences still here, till this particular A, you are able to find which are ending with C? None. Right? There are none. Let's move forward. Let's consider this particular case here. Let's consider both of these two things. Now tell me, in this particular string AB, how many subsequences you are able to find which are ending with A? Only the single A, right? Out of this, only a single A is the subsequence which ends with the A. How many subsequences you are able to find with the B, which are ending with a B, right? So AB, this is the only subsequence which ends with a B. And how many in this AB string, how many subsequences you are able to find which are ending with C? None actually, right? There is no C, right, till AB. So I'm going to keep it empty. Let's consider this test case now. A, B, C. Ending with A is going to stay A only. Ending with B, how many subsequences are there? Only one, AB. This is the last subsequence, right? AB is the one which is ending with B. Now, when we talk about ending with B, now not only like single B is also ending with B, right? But we don't consider these kind of things, right? We still have to keep in mind that here AI should be considered, here AI BJ should be considered, right? And here AI BJ CK should be considered. What I'm trying to say is that if you consider this particular test case AB, sure, AB is a subsequence which is ending with B, but B, single B is also a subsequence which is ending with a B, right? But we're not going to consider it because we are considering of type AIBJ only. So AIBJ type 1 is only 1 and this is it, right? Similarly here, ABC string, the type of AIBJ subsequence which is ending with a B is AB only, right? AIBJ type of subsequence which is ending with a C out of the string ABC. It is ABC only, right? Nothing too complicated. It is ending with a C and it is of type AIBJ. That's cool, right? Again, I'm repeating, I'm not actually, trying to talk about any formulas to solve this problem right now. We are just filling this out of plain logic right now. Just first try to understand the logic only, right? There is plenty of time to discuss what we are going to do in terms of formulas and all, how we are going to populate the DP with. But right now, we're not going to focus on that. Let's try to fill it only on the basis of logic first. Right. Now, AI type of subsequence, which is ending with a A in this particular area. One is surely this single A is there, right? This A dash is also is coming, right? In this particular subsequence, this A dash is also coming. So this A dash can stand in front of this A and form A dash. This is also a form of A power I. And A dash as a single can also start its own subsequence. Right? So these are all the three subsequences which are formed, which we can form, which are ending with the A and are of the form AI. I hope this is clear. Again, I will repeat this point. I don't think I'm not getting the satisfaction. So one is of course which we have to list here all the subsequences which are ending with the A, and one is definitely we can take from the previous test case, previous subsequence, previous subset, and that is simply just take this A. This is ending with the A. Another one can be this A dash can stand in front of A and form A dash. I'll just write it A dash. This is also a form AI, and this A dash can also start its own subsequence. So A dash is also one of them. I hope this is clear. Talking about B, it's going to stay the same. ABC is going to stay the same because if you consider this particular subsequence ABC like ending with C and AIBJ for formation, this is the only one. Ending with B and AIBJ formation, this is the only. I hope this is clear. Let's move forward. B dash. B dash wants to come now. This is the particular subsequence we are looking at. Right. Let's try to understand this. So when we talk about B dash, we are saying that B dash is ending with A. So ending with A. So A dash A. These are all just ending with A. Consider this whole string and talk about the ones ending with B. One is definitely AB, which is from the past. B dash can stand in front of B, this particular AB, and form B dash. Right. This is definitely the scenario, right? And one more thing, B dash can end with. B dash can stand in front of all these A's, right? To form AIBJ, yes or no? See, whenever a B wants to enter, B can join all the A's and it can stand in front of all the B's, right? A can stand only in front of all the A's or it can start its own subsequence, right? Similarly here, we are like this B took all what we were having before, plus it stood in front of all the ones we were having before. B can stand in front of B and B can also stand in front of A because we are trying to form of the form AIBJ. So all these A's, right? A dash, A dash, B dash can stand in front of all these. So these are all the formations B dash is able to form. One is taken from previous, 1 is taken from like previous, and we're trying to stand in front of all the ones which are ending with B earlier, right? This was the one which are ending with B, and we are choosing to stand in front of it. And one that, and all the other ones are the one which where we can stand in front of all the A's. Right? Here I'm trying to stand in front of all A's. B dash is trying to stand in front of all A's. These are all the 5, can say uh, formations we can make with this particular thing. All the subsequences we can make. I'm talking about C, right? C is going to stay the same, A, B, C. This is nothing new. So because C is, this is the only C which is which we are having till here. Right? So ABC is going to be the same. Right? Let's consider now. Let's move a little bit more forward. Now I'll just move the screen a little bit here. You just have to take inference that these are all the ones which are ending with A, all the ones ending with B, all the ones ending with C. Correct? Okay. Because otherwise it will hide behind my say camera. Right. So C dash wants to enter. Ending with A is going to be the same. Ending with B also is going to be the same because C dash is the one which is trying to enter. The one which actually tries to enter, their situation changes. Other ones, like situation stays the same. Now consider this particular thing. This C dash can stand in front of all the previous ones ending with C. So A, B, C is one of the answer which is ending with C. A, B, C, C dash is one of the ones which are ending with C. Essentially, we are doubling all the previous, you can say, subsequences. These subsequences can come as it is. Let's say there are like 2-3 more subsequences here, just for example. All these can have a say here, right? All these can get added here as it is, as just like this ABC is getting as it is, because only here we are talking about that the ones which are ending with C. So all these can come here as it is. So I'll just write down here. So previous ones can come as it is, plus previous can come as previous as new in front. I hope you are able to understand. Previous ones ABC plus new one in front C dash. So these are essentially getting doubled. I hope this is clear, right? And C can stand in front of who? All others. C can stand in front of all the ending ones ending with B, because what we are trying to form here is AI BJCK, right? So C dash can essentially stand in front of all the ones which are ending with B as well, right? So what we are going to do simply here, we are going to just keep the count of these here, and what we are going to say is that here all the ones which are ending with B, C dash can come in front of all those. How many of them are formed now? So 1, 2, 3, 4, 5, 6, 7, and this is the answer to this test case. All like total 7 subsequences are formed which are ending with AI, BJ and CK. Right. I hope you got the algorithm. I'll just write down the formula and let's try to fill it again. Right. I'll just write down the formula and let's try to fill it again. Let's consider the formula for this particular problem. It is pretty straightforward, right? So the thing is that let's say we are on a B, right? So we want to calculate that how many subsequences we can form which are ending with B. So what we're going to consider is that previous B's, is PB I'm writing, previous B's are going to come as it is, right? Plus I'm going to again write the count for previous B's. I'm going to count the previous B's again. Why? Because the current B can also stand in front of previous B's. Plus current B can also stand in front of previous A's. So whatever is the thing, right? B can stand in front of A and B. C can stand in front of B and C. So in case of C, the formula would be previous C's plus, again we are going to write previous C's because C can also stand in front of the C's, right? So previous C's plus whatever count of previous B's are, because C, this new C can also stand in front of previous B's. So this is the formula itself. But what about A, right? B can stand in front of A and B. C can stand in front of B and C. A can stand in front of A, previous A's, whatever A's are there. And it can also form a new A. So 1. It can start a new. A can be the first one, that this new A can be the first one to start a subsequence, right? So previous A's plus 1, that I'm starting a new one, plus No, there is actually nothing to plus here, right? Because on A is having nothing like before it. So A's has only this formula, B have this particular formula, and C has this formula, right? So keeping these formulas in mind, let's try to fill this particular DP array, right? Let's go forward. So when we talk about A's, this first A, right? This first A is going to have let's say one only, right? Because there is no previous A's. Since there are no previous A's, it is going to be 0. This A can start a new journey, and it is A single, right? Here we are going to write 0 only because previously there is no B and previously there is no C, so 0 is going to come as it is, right? B wants to enter. A are going to be the same. A are going to be as it is what we are here. Since we are on a B, here the change will actually persist. If we are on a C, the change will will be visible here. If we are on this B dash, the change will be visible here. Just keep in mind, if we are on a B, A is going to get copied as it is. B are going to look like what? B's are going to look like simply straightforward. Previous B's into 2. So 0 into 2 plus previous A's 1. This turns out to be 1. Essentially what we are trying to say is that this B will try to stand in front of previous AI BJ, but there is no AI BJ previously, right? And previous AI BJ can come as it is. There is no one. So 2 PB is turns out to nothing. And this A, now the B is also having one option to stand in front of AIs, right? So AIs is only one subsequence is there, which is A only. And when B tries to stand in front of it, it is the only subsequence it forms as AIBJ. I hope this is pretty much clear to all of you. Let's move forward. C is going to be like 0 only because there is no C as of now. We are on C, so A's are going to come as it is. We are on C, so B's are also going to come as it is. We are on C, so let's see what C has an option. C can stand in front of previous C's or it can stand in front of previous B's. Previous C's can come as it is 0, and this C can choose an option to stand in front of previous C's as well, but there is no previous C, so again 0. This C, like C can stand in front of C and C can also stand in front of B's. So now it will try to stand in front of all AI BJs. So only AB is the one. One is going to be written here, and the subsequence which is it's forming is ABC. I hope this is clear, right? Let's move forward, right? It will get more clear as we move forward, right? Right one. Let's consider this particular test case. AIs, right? AI has a single option. Previous ones can come as it is. So AI can decide to stand in front of previous ones, which is AI, and AI can start its new one, that is AI. So I hope this is clear to all of you. So previous A's can come as it is. This formula is actually incorrect. Previous A's can come as it is. The new A can try to stand in front of previous A's, plus it can start its new subsequence. So 2PA plus 1. Right? So whatever is the previous one, 2PB plus PA, 2PC plus PB. Right? This is the straightforward, you can say, solution, right? And these three form three particular things. What we are trying, I'll again repeat this particular test case. I think it was not clear earlier. We are talking about A dash. A dash, like right now we want to write all the ones which are ending with A. This single A ends with a A, good. A dash can decide to stand in front of the single A, so A dash, good. A dash can decide to start its new one, so A dash. So 3 is the one. This is the answer for this. Here, this is going to stay, and here this is going to stay. Let's consider this test case. So I'll just write here. So A dash, A dash, right? Let's consider this. So these three are going to stay as it is. So A dash, A dash, right? Let's consider this particular case. So what is the formula? Previous B's can come as it is, and this B dash can also stand in front of the previous B's. Plus this B dash can also stand in front of previous A's. So PA. What is the formula? Previous B's is AB. When we decide to stand in front of previous B's, we form AB B dash. When we try to stand in front of previous A's, we form all these ones. 3 is going to come as it is. So A, B, A dash, B. So this is B dash. A dash, B dash. I hope this formula is pretty clear to all of you. C, right? B can stand in front of A and B. And here 1 plus again this 1 plus this 3. So this forms 5. So 5 of them are here. I'll just write them quickly. So AB as it is. A, B with a B dash. B dash decides to stand in front of the previous B's. And B dash decides to stand in front of previous A's. So A, B dash, A dash, B dash, A dash, B dash. I hope this is clear. C is going to stay as it is, A, B, C. C is going to stay as it is. Let's move forward. Let's get to this test case. This is going to be a final test case. We're going to solve this problem, right? C dash is the scenario. Right? See, when we talk about C dash, this A block will be filled as it is with the previous ones. This B block will be filled as it is with the previous ones. This C block is now going to get filled. Now C can, previous C's can be considered to PC. This ABC is the previous one plus PC, because this C dash can decide to stand in front of previous C's as well. So what we are going to say is that A, B, C, C dash. The C dash is deciding to stand in front of previous ones ending with C. And this C dash can also stand in front of the ones which are ending with a B. So A, B, C dash, A, B, B dash, C dash, A, B dash, C dash, A dash, B dash, C dash, A dash, B dash, C dash. How many of them are total? So 1 plus 1, 2 plus 5, 7. So all of these are total making of 7. And in this particular block, your answer will lie. I hope this problem statement, this solution to this problem is clear itself. It might seem that we will create a 2D array for solving this, but actually no. We are going to solve this problem with O of 1 space complexity. O of n time complexity and O of 1 space complexity. How we are going to do it? See, if we look closely, we just need to keep a track of what was there in the previous state, right? We would have required 2D DP if we let's say this particular state depends on this state, but no. Whatever this state is, it depends on the previous state itself. So whatever this state is depends on the previous states itself. So we're going to just maintain the three variables which are which are representing the previous states, and then we are going to solve this particular problem only using those three variables and returning the answer. It's a straightforward solution using these formulas. I hope these formulas is clear to all of you. If not, you can just rewatch the video, or maybe tell me in the comment section what you are feeling, how this explanation was and all. Let's try to quickly code this out and finish the question itself. So we are going to solve this problem on GFG itself. We just quickly, quickly code this out. So first state which I want to keep in mind is previous A's. Right? Previous A's is going to be 0. In previous B's is going to be 0. In previous C is going to be 0. I hope this is clear. Now we are going to iterate on the string. For int I is equal to 0, I less than s dot length, I plus plus. Here what we are going to do is, let's say we are going to define three variables: current A, current B, current C. Just for the sake of simplicity, I'm going to expand my code. My code will be longer, but it will be easier to understand, right? I can make this code shorter, but you can optimize on that. Shorter in terms of the number of lines I'm writing, right? So nothing better in time complexity. It's still, O of 1 space, O of n time complexity. But what I'm trying to say is, whenever I will write the code, I will write it in such a way that, all the students are able to understand the code, right? It is easier to understand rather than it's a complicated code, but it's a shorter one. Shorter one is not the target here. Everyone understands the target, right? Let's quickly move forward. If s dot char at I is equal to a, we have to do something else. If this particular thing is having a b, we have to do something else. Else we are going to do something else. Okay, forward. When we are standing on a, I'll just increase the font size a little bit. When we are standing on a, what do you think we should do? When we are standing on a, current a becomes what? 2 into previous a's plus 1. Straightforward. Current b becomes previous b, and current c becomes previous c. That's straightforward. When we are on a B, right, let's rewrite these equations. Right? Previous A is going to be as it is, previous C is going to be as it is, but previous B become 2 into previous B plus previous A. And similarly for, the third case, right, when we're talking about C's, right, we're talking about C's, this previous B is going to stay the same as previous A is going to stay, right? Please go ahead it. So let me just reformat it. So 2 into previous C, because C can stand in front of, yeah, all the previous C's can come as it is, or the C can stand in front of the previous C's. Plus it can also stand in front of previous B's, so the count of previous B's is added. I hope this is clear. In the end, after you have decided what all are the current scenarios, you just need to set the current thing to the as a previous thing, because I will be incremented and we will move on to the next character. So all the current ones will become the previous ones for the next character. So previous A is equal to current A, previous B is equal to current B, previous C is equal to current C. I hope this is clear. What we are going to do is we are simply going to return previous C. That is, there will be the answer which will lie. Let's compile and run this, see if it's passing the test cases or not. Session expired. Let me refresh the page and let's compile this and run. Right, it's giving the correct answer. Let's write a custom input. This is the custom test case. Let's try to compile and run. The answers for this should be 27. Let's see if the custom input got used. Yeah, so answers coming as 27. It's working fine. It will not actually get submitted because of one thing they have mentioned in the last of the question, which is you have to take modulo 10 to the power 9 plus 7 in every solution. I think this point we have discussed earlier as well. So let's quickly formulate this and modulo 10 to the power 9 plus 7. Wherever we are doing mathematical calculations, right, we are going to write modulo 10 to the power 9 plus 7. So I'll just keep here int md is equal to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 7. So there are multiple ways to write this expression. I'm just writing the simpler way. So here we are going to do what? I'll just do mod md here as well. Wherever we are doing a mathematical operation, mod md, and here also we're going to do mod md. In the end as well, let's just for the sake of clarity, let's do mod md. Let's try to submit this now. Let's see if it gets submitted or not. If not, then we'll have to add mod here as well. I think it's failing and it's the same reason. So we'll have to write here as well, like this mod md. Here as well, we'll have to add mod md. Correct. Let's compile this and run this now. We would have used the older test case. Submit this. So it's passing all the test cases. Basically, whenever you need to write module transform and wherever mathematical operations are getting done, and wherever you think that it might exceed the integer limit, you have to wrap that expression in a bracket and add mod it with the largest prime number in integer. Right? So, okay. I hope this is clear. This solution was pretty straightforward, right? O of 1 space complexity and O of n time complexity. This is it for this particular question. I hope you're enjoying this dynamic programming series, right? Please do tell me in the comment section if you like the video or not. Right? Any suggestions you have, any quality related suggestions you have, you can definitely throw them in the comment section. So yeah, and please do subscribe to the channel. We are aiming for 1,000 subscribers. Thanks a lot for watching this video till the end, and yeah, keep coding, and until next video, dogs.